Imagine you are standing in the middle of a vast open field on a moonless night, with only the twinkling light from billions of stars illuminating the sky above. The gentle whisper of the wind rustles through the tall blades of grass, carrying with it the crisp chill of the enveloping darkness. You lift your head, and it feels as though the entire universe is murmuring ancient secrets that humanity has labored tirelessly to uncover for centuries upon centuries. From the dreaming philosophers of ancient Greece who pondered the layers of the heavens, to the modern astronomers who perch in observatories nestled amid barren deserts, the question of the universe's true form has perpetually twisted and turned the human mind in knots of wonder and frustration. This universe, so immense and shrouded in mystery, what shape does it truly possess in the end? Is it a sealed sphere, an endless flat plane, or perhaps something utterly bizarre that our imaginations have yet to grasp? The journey to unravel the shape of the universe. The tale commences from epochs long past, when humankind lacked even the simplest telescopes or intricate satellites to peer into the cosmos. Though the universe appears boundless and ever-shifting, scientists have long believed it must harbor some underlying structure, some definitive geometry. Picture yourself gazing upon an ancient map, its lines faded and indistinct, and envision scientists as intrepid explorers striving to sketch the grand panorama of the cosmos from mere scattered fragments. In recent years, advancements like the high-definition images from the Atacama Cosmology Telescope released in March of 2025 have provided unprecedented clarity, depicting the cosmic microwave background radiation from when the universe was a mere 380,000 years old, adding layers of detail that refine our understanding of its early geometry. As researchers meticulously dissect data from the universe's primordial era, those faint signals of light originating from just a few 100,000 years following the Big Bang, they have stumbled upon startling revelations. The data derived from the cosmic microwave background radiation, that dim glow lingering from the universe's nascent moments, initially suggested the universe might be curled like the surface of a balloon, smooth and seamless. Envision holding an inflated balloon in your hands, its skin flawless, devoid of any starting point or terminus. Yet, subsequent evidence has pointed toward an alternative reality, a flat universe, akin to an enormous sheet of paper extending infinitely in all directions. The latest observations from the South Pole Telescope, updated through 2025, further bolster this view, delivering exquisitely sensitive measurements that signal a new era in probing the universe's first light and confirming its near-flat curvature with even greater precision. To comprehend this concept, consider two beams of light emanating parallel from a single origin, much like two bicycles pedaling side by side along a lengthy straight road. In a flat universe, these beams would remain parallel indefinitely, never converging. However, should the universe resemble a sphere in its curvature, those beams would arc gracefully and ultimately intersect. This enigma has tormented generations of scientists, prompting endless deliberations. The scratch of pens across paper in dimly lit studies, the hum of computers whirring in sterile laboratories, and the marathon debates stretching through nights beneath harsh fluorescent lights, all revolve around this profound puzzle: is the universe flat or curved? Recent cosmological efforts, such as the innovative search strategies outlined in Quanta magazine in January of 2025, are now mapping subtle signals that could definitively reveal the universe's topology, employing topology to probe shapes in ways that traditional methods overlooked. The expanding universe and its destined scenarios. Everyone is aware that the universe is expanding, much like a balloon being steadily inflated, growing larger with each passing moment. Imagine yourself positioned at the heart of a bustling metropolis, observing towering skyscrapers receding from you in every conceivable direction, not because they are fleeing, but because the very fabric of space between them is stretching apart. Potent telescopes, such as the Hubble Space Telescope and the James Webb Space Telescope, have captured visions of distant galaxies, their light traversing billions upon billions of years to reach our planet, revealing they are hurtling away from us at breathtaking velocities. The symphony of data processing, those rhythmic beeps emanating from computers as scientists pore over the influx, carries a thrill mingled with trepidation. Whither does the universe journey next? Intriguingly, Findings from PhySorg in November of 2025 suggest that this expansion might now be decelerating, rather than accelerating as once presumed, mounting evidence that challenges our grasp of dark energy and prompts re-evaluation of the universe's long-term trajectory. There exist three principal scenarios, hinging upon the density of matter within the universe, that is, the quantity of matter dispersed across a unit volume of space. Scientists have calculated that the current universe contains approximately 6 hydrogen atoms per cubic meter of space. This figure seems minuscule, yet when scaled to encompass billions of light-years, it swells into an astronomical mass. This density dictates the universe's fate, akin to a chef meticulously measuring flour to craft the perfect loaf of bread. Emerging theories from the University of California, Santa Cruz in August of 2025 propose that dark matter might originate from a mirror world, a hidden sector that could subtly influence this density and thus the universe's overall shape and expansion. The closed universe, with positive curvature resembling a sphere, should the matter density prove sufficiently substantial, gravitational forces would overpower the expansion. The universe would contract, like a balloon slowly deflating, culminating in a cataclysmic collapse termed the Big Crunch. Thereafter, a fresh Big Bang might ignite, birthing a reborn cosmos. Envision traversing the Earth's surface endlessly, only to circle back to your departure point. A spherical universe mirrors this finite yet boundless nature. The howl of winds through contracting space, galaxies colliding in fiery embraces, the brilliant flares of supernovae illuminating the void, paint a vista both majestic and terrifying. Though less favored today, this model gains renewed intrigue from topological studies at the Georgia Institute of Technology in February of 2025, which use mathematics to explore how such a shape might manifest in observable phenomena. The open universe, with negative curvature akin to a saddle, if the matter density falls too low, gravity lacks the strength to curb the expansion. The universe would balloon outward eternally, galaxies drifting ever farther, space cooling into an icy, desolate expanse. Its form evokes a saddle, dipping concave at the center. Picture standing upon a winding trail that curves outward on both flanks, extending infinitely, that is the open universe, boundless and ceaselessly enlarging. The flat universe. This remains the most robustly supported paradigm in contemporary cosmology. The matter density precisely balances to temper the expansion without halting it entirely. The universe will expand forevermore, though its pace will taper toward zero over infinite time. Galaxies shall continue their recession, yet more languidly than in an open configuration. The image of a vast, level sheet of paper unfurling without end offers the simplest visualization. The clatter of keyboards as scientists scrutinize data from the European Space Agency's Planck satellite resonates like a triumphant anthem. The universe is flat, with a margin of error of a mere 0.4%. Bolstering this, the James Webb Space Telescope's observations in 2025, as detailed in SCI Tech Daily in May, have recalibrated the universe's expansion rate, potentially resolving long-standing discrepancies and affirming the flat model's endurance. Relativity and discoveries from telescopes. Thanks to Albert Einstein and his theory of relativity, we comprehend that mass warps space, much like a heavy ball depressing a taut trampoline. If the universe accumulates enough mass, gravity triumphs over expansion. Yet modern observations, particularly from the Planck mission spanning 2009 to 2013, and the freshest insights from the South Pole Telescope in 2024 and beyond into 2025, indicate the universe's curvature verges perilously close to zero. The universe is flat to an astonishing 99.6%. The clearest images yet of the 380,000-year-old universe, unveiled by Princeton University in March of 2025, reveal temperature fluctuations in the cosmic microwave background with exquisite detail, further solidifying this flatness by showing no distortions indicative of curvature. To verify this, scientists harness the cosmic microwave background radiation, the most ancient light observable, originating 46.5 billion light-years distant. Satellites like the Wilkinson Microwave Anisotropy Probe and Planck have discerned minuscule temperature variations, a mere 1 part in a million degrees. These warmer and cooler patches coalesce into colossal galaxy clusters spanning hundreds of millions of light-years. In a curved universe, such fluctuations would distort, as reflections in a warped mirror. But they persist unaltered, attesting to flatness. The Simons Observatory, commencing operations in 2024 and yielding results through 2025, hunts for Big Bang echoes in this oldest light, promising even sharper insights into dark matter and neutrinos that underpin the universe's geometry. Envision launching a spacecraft into the void, directing it to veer 90 degrees 4 times along equal segments. In a flat universe, it wanders eternally without return. In a spherical one, it loops back after 3 turns. Yet the universe's vastness renders such voyages infeasible across millions of light-years. Instead, scientists voyage via light, scrutinizing the cosmic microwave background and remote galaxies. The rumble of the James Webb Space Telescope's mechanisms as it pivots to photograph galaxies from 13 billion years past evokes standing at a portal to antiquity. Recent Webb data from 2025, as reported by the University of Chicago, suggests our foundational cosmological model may endure after all, with refined expansion rates aligning closely with flat universe predictions. The observable universe and our boundaries. The observable universe, the portion visible to us, spans a diameter of approximately 93 billion light-years. Yet this constitutes but a sliver of the actual cosmos. Light from the remotest galaxies, such as GNZ11 located 32 billion light-years away and formed when the universe was a tender 400 million years old, requires billions of years to arrive. The James Webb Space Telescope, launched in 2021, has extended these frontiers, detecting galaxies with redshifts up to 13, corresponding to epochs mere hundreds of millions of years post-Big Bang. Nevertheless, we are constrained by light's velocity and space's relentless expansion. Imagine stationed at a cosmic nexus, surveying all horizons, galaxies fleeing uniformly, fostering an illusion of centrality. Relocate to GNZ11, and the sensation persists identically. No epicenter exists, no perimeter. The universe, flat and infinite, resembles an edgeless parchment. The chill winds sweeping the Atacama Desert, where the Atacama Large Millimeter Array observes, serve as a humbling reminder of our insignificance. NASA's forthcoming space-based quantum gravity sensor, slated for launch in 2025 as announced by the Quantum Insider in April, will map Earth's gravitational shifts from orbit, but its principles could one day illuminate larger cosmic curvatures. Unresolved enigmas. Though we affirm the universe's flatness, myriad queries linger. The arrow of time, why does it inexorably advance forward? Entropy, the measure of disorder, invariably escalates, as when a glass shatters irreparably. Dark matter and dark energy comprise 96% of the universe, known solely through gravitational imprints, invisible and intangible. String theory posits 10 or 11 dimensions, extra ones coiled tighter than 1/1,000,000th the atom scale. Black holes, via Hawking radiation, defy notions of information preservation and reality itself. The Dark Energy Spectroscopic Instrument Collaborations map released in October of 2025 hints at standard model fractures, urging fresh paradigms for these shadows. Future technologies and dreams of cosmic conquest. Investigations into quantum antigravity propulsion, including Russia's project from 2009 to 2014 and NASA's Ion radio frequency thruster trials, promise Mars voyages in 42 hours. Cold fusion reactions, though contentious, herald boundless energy. Envision the thrusters roar as spacecraft depart Earth, azure glows from fusion reactors piercing cosmic night. NASA's 2025 Innovative Technology Concept Studies, awarding up to $2.625 million in grants, evaluate propulsion innovations for deep space, while Lockheed Martin's space technology trends for 2025 spotlight quantum sensors and advanced satellites revolutionizing exploration. Life out there. Telescopes like the Transiting Exoplanet Survey satellite and the forthcoming Plato mission from the European Space Agency in 2026 have unearthed thousands of potential planets. One orb, 691 light-years distant, boasts an oxygen-rich atmosphere and oceans cloaking one-third its surface, hinting at habitability. Traces of colossal moons, 500 kilometers across, abandoned for millions of years, provoke queries: whither vanished other civilizations? The lap of distant waves, zephyrs over alien continents, might someone heed Earth's greetings from 2289? By July of 2025, the Transiting Exoplanet Survey satellite catalogued 7,655 candidates, 638 confirmed, including ringed worlds evoking Saturn, as reported by FISORG in May of 2025, expanding prospects for diverse life forms. This flat, infinite, expanding universe renders us specks of dust in its grand narrative. Yet curiosity and resolve to explore render humanity extraordinary. Whatever the morrow holds, verdant Earth endures as our cradle, whence we embark to claim the stars. The article has been substantially expanded, incorporating vivid descriptive details, the most recent scientific insights, and a seamless narrative flow for enhanced immersion. If you require further elaboration or a focus on a particular facet, kindly inform me.